Every autonomous system in the history has needed two things: the ability to act and a reliable model of world is acting on. The second one is what mostly haven't built for AI in production. That's what this talk is about. I'm Eran Bibi. I'm the co-founder and chief product officer at Firefly, automated cloud resiliency platform for cloud-native teams. We help teams to get their entire cloud footprint as code. In this session, I will talk about the gap I think the most of the AI SRE space are still working around. The right pattern to allow AI agent to safely change and control cloud infrastructure. I will share what is the analyst take and their predictions, and I will show a short demo to highlight why cloud context is essential for agentic IAC. Look at the SRE Summit agenda. Almost every talk so far has been about the read path: telemetry, observability, calibration, SLO for agents, root cause analysis. That's the right place to start. But there is a right path too, the part where the agent actually changed the cloud. Picture this: it's 2 a.m., you got a page. Your AI SRE agent correlate the signals, find the root cause, apply the patch directly on the cloud. 12 minutes, resolve. Beautiful. 3 weeks later, similar incident, similar fix. 12 minutes, again, very fast. 6 weeks later, the same path. Three perfect green dashboard. Everything seems fine. The AI SRE did exactly what it's supposed to do. He resolved the issue. The problem is he created three different resource drifts. The change done directly to the cloud. Every fix didn't make back into the ground truth. The agent did its job, but its system got less reliable anyway, because resolve mark is not closed in the loop. So this is how a modern ClickOps look like. Back in the days, ClickOps was when somebody, a human, go to the cloud console directly and do some actions directly in the cloud without doing it via infrastructure as code. But the modern ClickOps is just an agent doing the exact same thing. And in any case, we should avoid that. So what you see here is a map. On the left, it's the read path. Telemetry logs, metric traces, what the agent sees. This is mature. This is AI SRE as for the moment. In the right, there is the right path. Infrastructure as code, live cloud state, policy as code for guardrails, dependency graphs for blast radius. What the agent can change durably. Most of AI SRE today live entirely on the left. And this is that ceiling, because real autonomy needs both. Let's look on the analyst. These aren't my numbers. This is from Gartner Market Guide for AI Assistant for Infrastructure as Code, published in late March, just a few weeks ago. Gartner is calling 70x shift in 3 years. Less than 1% of enterprise are using agentic AI for IAC today. But by 2029, 70%. And 90% of the infrastructure and operation orgs will have context-aware AI assistant integrated into their IAC workflows. That kind of velocity only happen when something becomes table stakes. So the question in this talk asks is, what does the AI layer actually have to look like for that to work? Gartner draw a curve like this: manual scripting, AI assistant, and agentic. 3 columns, 3 reliability postures. Most of the teams in this room somewhere between column 1 and column 2. The third column is where we are adding. The gap between the 2 and 3 is bigger than its look. It's not a model upgrade. It's an architecture change. Here why most of the team are trying to wire a general purpose LLM into their cloud hit the walls. 3 failure mode. 1, hallucinated infrastructure. The agent generate beautiful code referencing VPC and subnets and IAM roles that doesn't exist in your account. 2, generic template. Code that look like compliant but violate your specific guardrails. 3, no blast radius awareness. The agent suggests a fix that work in isolation and break 3 downstream services. The agent isn't dumb. It doesn't have a ground truth. It's reasoning. It's vacuum. So this is an abstract. The layer that turn IAC into usable ground truths for an AI agent. Let me walk bottom up. The cloud is the world. The agent is the actor. The interstudy layer is the one in the middle. Ground truth isn't just an IAC repo. It's the IAC repo plus the live cloud state plus the difference between the IAC and the actual cloud, what we call drift, plus the dependency graph that tell you what depend on what. Without all of those 4, the agent can't reason about the consequences of the changes he is about to do in the cloud. It can only generate placebo sound code. And then on top of that, you need a deterministic layer, deterministic guardrails, approval workflow, audit trail, the agent propose, the CI dispose. This is what kept the autonomy safe and scale. The model on top is almost doesn't matter. The substrate does. When IAC agent ground truth drifts stuff being an annual cleanup task because it's a first class signal. The same kind of signal an SLO burn rate is. Because every drift event is an agent telling you, my model of the world is no longer match the world. That's not an hygiene. That's integrity alarm on your autonomy layer. And if you take one thing from this talk, let it be that. Drift is a reliability signal. Treat it like one. And let's see how this pattern should look like when your AI agent is actually changing the cloud via infrastructure as code. So there is a drift, there is a reliability issue, something need to be changed in the cloud. The AI is identify the place in the code where the configuration need to be changed, whether it's a scale, whether it's a security group that need to be adjusted, is doing the change, is creating a PR, an ISC pipeline is kicking off, and all of the guardrails and the safeguards are being placed. No manual change in the cloud, everything is being audited, the template become the single source of truth. If you need to reprovision that in a different environment, you have the exact patch in your end, you don't need to remember anything. This is the actual way to manage cloud infrastructure using agents. Most of the production cloud isn't fully in IAC, especially in large companies. These are long tails of ClickOps, console changes, things that were provisioned by someone who left the company, I don't know, 5 years ago. Maybe the company also acquired infrastructure nobody touched in years. Agent that can read live cloud state can produce IAC for it. So if retrofitting for IAC was a tedious task back in the day, now we can leverage AI and agentic AI in order to close that gap. It's not greenfield, It's not a new shiny project that everybody have blueprint for. It's codifying what you already have. This is the boring part of doing IAC, right? It's understanding the cloud, understanding how to modelize it, how to use our existing IAC and not trying to create a brand new manifest that are not aligned with the best practice and the knowledge you already can. Right now, with AI agent, with the models that are smart enough, you can do that retrofit very easy and make sure that all of your cloud infrastructure, regardless when it was created and how it was created, is described as code. So to conclude, the pattern that we are looking for when using agentic AI to manage the cloud is not about provisioning and changing cloud directly using AWS CLI or MCP or any type of direct connection. Is to have a working layer of IAC, a ground truth layer that is understanding your cloud, making sure there is no drift because drift will be the exact anti-pattern we are looking for, and making sure that you have a deterministic pipeline with guardrails that even if the IAC, the agent is hallucinating, there is a safeguard to make sure that all of the changes that are proposed are safe and are compliant with the company policy. Here's where I land. If Gartner is right, and we are going from less than 1% to 70% in 3 years, the org that come out ahead aren't the ones or best models. They are the ones whose agents are at the best ground truth. The teams that own their IAC, that codify their brownfield, that treat drift as a reliability signal, that wire CI policy scan as a judge and as a guardrails. Those teams are going to find out their agent can do enormous amount of real work. Those teams that own the IAC will own the agent. IAC what the agent using in order to close the loop. Let's have a quick demo that will show you few option of how to use AI with IAC and why a context is very important in order to have a very good path to control your cloud. Okay, so what I'm going to show you is how I'm using Claude Code in order to generate a simple IAC. I will ask him to generate Terraform manifest for an EC2, which is a VM instance. I didn't provide any further instructions. I'm using, in this case, Opus 4.7, the latest one, and I'm expecting him to do a very good job with generating that type of simple Terraform. And as you can see, it's creating a main TF, asking my permission to write a file. I give in my consent, and browsing through the main TF seems very straightforward. A Terraform block with a provider, AWS, and of course, the actual resource block, which is the AWS instance resource block, everything in one file. Pretty sure that is going to create a VM. But the second phase is to give some skills. And here, what you can see, this is the Terraform skill written by and maintained by Anto Babenko that is famous about generating Terraform modules. This skill says almost something like 2K stars and growing. Very good skill because it's accumulate a lot of knowledge and pattern and know-how of how to create best practice when writing an OpenTOF and Terraform. So what I'm doing right now, asking Claude to install this skill. Again, very simple action. You can do that for that specific session or in general. And you can see that he's creating a .claude folder in my workspace with a setting JSON and asking my permission to actually deploy that skill in my workspace and generating a skill.md file that include the actual instructions. So that additional context is basically another layer of how you should use an IAC with AI. And I ask him to just edit my request of generating the EC2 with the knowledge that it just accumulate. And what I'm expecting to see right now is all of the changes that he's done. So he's got the same instruction: generate Terraform for EC2. I didn't give another instruction. I didn't elaborate on the environment or the spec. And as you can see, just by importing that skill, is creating a different type of template. First of all, it's creating multiple files. It's not just the main TF, it's also a variable file, version.tf. You can see there is a validation block, meaning he also embedded some regex condition for the instance type to make sure that I'm not accidentally using a family size that is very expensive or over budget. So those stuff are out of the box, right? Those are like the default type of knowledge you have. I didn't ask for it, but you know that in order to create a best practice IAC, you need to have those in place. And this is something that I'm very happy for. So again, same request, totally different result with the same model, just because we accumulated a skill. So it's very important to do that. Now, the third layer, I'm asking him to have a context-aware situation. So in this case, I'm using the AWS CLI that is already configured with an AWS profile against my AWS account. And I'm asking him that will discover the account and will redo my request based on the existing infrastructure. So I didn't explicitly say what to look for. I just say, you have an access to my account, so please create that EC2 instance while having the knowledge of what is already in there. And as you can see right now, is trying to authenticate to my account using the AWS configure command. Now that it's sorted out, which account exactly, because I have a multiple profile, is going to query my AWS account in order to identify what kind of other resources are being there that might be incorporated with my template. And as you can see, some of the examples of the queries that he's doing describe for a few resources. So he's looking for VPCs, subnets, API keys. So everything that is an input for a plain vanilla EC2 is checking what I have in my account. And as you can see here, there is few results, my subnets, my VPCs, and some of the keys that I already have there for other type of EC2s. He also figure out that I have a strict tagging convention for the EC2s that are already in my account. So he know that I'm expecting to have a name, but also a team and environment. And again, I didn't mention that in my ask, in my prompt. He realized that by analyzing the cloud and getting the context aware for the manifest. So what he's doing right now, if you see in the right side, is updating my main TF to include everything that you realize that is fit for my account. And this is exactly what I mentioned in my slide deck. The context of the cloud is very important, and it's a key for a successful provisioning of cloud infrastructure using IAC. And that layer, that knowledge, is something that you need to use, whether you're using CLI, and again, for read only, of course, to get information, or using MCP, or using other tools like Firefly, that is allowing your agents to have those type of contexts. And the IAC generation is not being done in a vacuum. It's not being done without understanding exactly what is there. So you can see the result. You understand what is the VPC ID, what kind of subnet I'm using, whether I have a security groups, and key to use, and it just updating. So you can see the evolution between a prompt that is asking an EC2 instance manifest with a plain main TF, very simple, out of context, then adding the layer of the knowledge using, in this case, the Anton Babenko Terraform skill. There is also HashiCorp Terraform skill available. And then the third layer of giving the context of the existing cloud. And there is also additional context like the actual repository or the existing IAC repository. I didn't show that in demo, but this is also a very important pillar. What kind of IAC template you already have today that you are using? Those kind of context is a key for a success of having an AI agent using IAC. So that's it. Thank you for watching and thank you for participating in this session. If you would like to learn more of how to use AI agent with IAC production grade, this is emerging space. I'm excited about it. You can reach me out in LinkedIn. Thank you again for listening. Take care.